When using any Dow Corning brand silicone joint sealant, make sure that you are following all safety guidelines, including the use of correct personal protective gear. You must also comply with local, regional, and federal safety guidelines. For each Dow Corning sealant, thoroughly review the Material Safety Data Sheets, or MSDS, before using the product. The MSDS are available at dowcorning.com or by contacting the Dow Corning Technical Information Center at 800-248-2481.
Dow Corning 890 SL self-leveling silicone joint sealant is an ultra-low modulus sealant that is formulated for use with asphalt and Portland cement concrete.
Our sealant's excellent performance depends on several factors in the field. To get the maximum performance, Dow Corning sealants must be properly installed in joints that are properly designed and prepared. The first step for long-term sealant performance is proper joint design. The correct width and depth of the joint is critical to future effectiveness and longevity of the sealant. Because Dow Corning 890 self-leveling sealant has 100% extension and 50% compression capabilities, then a half-inch sealant joint, for example, can be expected to extend to 1 inch and compress to 1/4 inch. But because pavement expansion in the field may be different than in the lab, we recommend that a safety factor of 2 be calculated into the design. If the total expected movement is 1/4 inch, the joint width should be a minimum of 1/2 inch. This gives a safety margin to prevent cohesive and adhesive failure should the joint move more than anticipated. Once the joint width has been determined, the depth of the joint can be calculated. The sealant must be recessed a minimum of 3/8 of an inch below the pavement surface for joints less than 1 inch wide. For joints wider than an inch, the sealant should be recessed deep enough to prevent tire contact. The thickness of the sealant bead should be a minimum of 1/4 inch and a maximum of 1/2 inch. The backer rod should be approximately 25% larger than the joint width. So for a 1/2 inch wide joint, this adds up as 3/8 of an inch recess plus 1/4 inch of sealant plus a 5/8 inch backer rod for a total of 1¼ inches. To allow for actual field conditions, an additional 1/8 inch is added, bringing the total depth of the joint to 1 3/8 inches. In some remedial work, up to an additional 1/2 inch may be necessary. For joints that are 1 to 2 inches wide, the maximum bead thickness of a silicone sealant should be 1/2 inch. Joints are designed so the walls are generally perpendicular to the pavement surface and have a rectangular reservoir. Where field conditions prevent a strictly perpendicular angle, small spalls can be sealed. With the proper joint design, the field work is ready to begin. In new construction, the first step is to green saw the concrete at desired spacing to allow the concrete to crack at controlled locations. After this, the initial control crack cut is resawn to increase its width and to form the joint sealant reservoir. The joint should be immediately washed clean with high-pressure water. The water pressure should be high enough to remove the latents connected with the sawing process. Flushing should be in one direction only to prevent recontamination of the joint faces as the washing moves from one joint to the next. After the joints have been washed, they need to be thoroughly dry before the next step. Depending on the weather, this may take a few hours or several days. As a rule of thumb, the joint can be considered dry when the concrete is white in color and no water is standing at the bottom of the joint. Once dry, the joint should be sandblasted. The sandblasting process should be powered by a compressor capable of at least 120 pounds per square inch and 60 cubic feet per minute. Sandblasting abrasive needs to be directed toward each joint face to make sure that it is clean, and should be concentrated on the top inch of the joint faces where the silicone sealant will need to adhere. The sandblast nozzle should be no more than 2 inches away from the joint face. An advantage of sandblasting is that the joint is being prepared dry, so the next steps can proceed without delay. Because the moisture content of the concrete plays a major role in the cure and adhesion of silicone sealant, it is recommended that new concrete should cure for at least 7 full days in good drying weather before the sealant is installed. Right before installing the backer rod, the joint and surrounding areas should be blown clean of all dust using compressed air of at least 90 psi. Air compressors must be equipped with traps capable of removing moisture and oil from the compressed air line. Recommended joint preparation for remedial work is similar to new construction. First, the joint size needs to be calculated. Remember, removing old sealant material may widen the joint somewhat. The removal may take different forms depending on the type of old sealant. For hot and cold applied sealants, the first step is to remove the majority of the sealant. Then the joint faces should be sawn back to a clean concrete face. To do this, you may have to remove just a few mils of concrete or entirely reface the joint walls. If this sawing process uses water, then the new faces need to be washed to remove all latents. After drying, the joints need to be sandblasted and then blown clean, as described earlier. On preformed joint material, the seal material should be pulled out if it is still present. Then the joint faces can be sandblasted to remove residual glue that helped hold the preformed material in place. Once this is done, the joint is blown clean with compressed air. After the joints, either new or remedial, have been prepared, they must be checked to make sure that they are clean. Gently rub the side of the joint with your finger to check for dust. If you find dust, like chalk dust from a blackboard, then the joint needs to be re-cleaned. In all cases, the joint must be clean and dry before installing the backer rod. The backer rod has two major functions with the self-leveling sealant. First, it prevents the sealant from adhering to the bottom of the joint, and it controls the depth of sealant placement by plugging the joint. If the backer rod doesn't completely plug the joint, you'll experience a sinkhole or a product rundown problem. The use of a soft-type rod as a backup material is suggested, particularly when the joints are not a consistent width. Also, Dow Corning 888 silicone joint sealant can be used to plug gaps between the backer rod and concrete. Expanded closed-cell polyethylene backer rod may also be used, but doesn't offer the same forgiving features as the soft rod. Open-cell backer rod should not be used. The backer rod should be 25% larger than the joint width. The backer rod is installed in the joint using a roller device. This roller needs to have guides on the outer edge so the rod depth is controlled. It may take 2 passes with the roller to force the oversized backer rod into the joint to the proper depth. For applications where the joint is too shallow for backer rod, bond breaker tape may be used instead. Placement of the backer rod should be done carefully. Sharp or pointed objects should not be used because they will puncture or break the rod. If this happens, outgassing may occur, causing bubbles in the sealant as it cures. The backer rod should be placed deep enough to accommodate the recess and sealant bead size calculated earlier. At the junctions of transverse and longitudinal joints, the backer rod can be cut out in one of the directions before the placement of the second direction. This will provide the proper depth for all of the sealant and reduce material consumption. When the silicone is placed, all silicone intersections need to be tied to a clean, uniform silicone surface. For concrete shoulders, the backer rod and sealant should continue from the mainline pavement to the outer edge of the shoulder. With asphalt shoulders, the backer rod should be terminated at the edge of the mainline concrete. Use sealant to seal the end of the joint and fill the remaining saw cracks. Dow Corning 890 SL sealant does not require primer with Portland cement concrete or asphalt. So, with the backer rod properly installed in a clean, dry joint, the next step is to place the sealant. In some instances, compressed air may be needed to blow out debris deposited by wind or traffic moving past. Dow Corning 890 SL sealant should be pumped directly from the original drum or pail. The equipment needed to install the sealant can be manually or air power operated. Powered equipment is recommended because of the speed and ease of application. Manually operated equipment can be successfully used for small applications such as patching test sites or bridge joints. The major pieces of power equipment required for installation are an extrusion pump to transfer the material from the container to the joint and an air compressor capable of delivering air at 60 CFM and 120 PSI. Complete units, including air-powered pump, follower plate, and hoses, are required for pails and for drums. Air-powered extrusion pumps are available in different output capacities. Higher ratio pumps have greater delivering capability. Specific ratios may vary among manufacturers, but a ratio of 35:1 is the minimum capable of delivering a sufficient volume for efficient operation. Regardless of which pump system is chosen, some features are recommended. Because this sealant cures on exposure to atmospheric moisture, the seals, hose connections, and hoses should be selected to prevent or minimize moisture permeation. They must also be able to withstand pumping pressure and resist abrasion on the job site. Teflon-lined hoses are recommended because their low air and moisture permeability will provide long, trouble-free service. Unlined hoses are not recommended because they allow enough moisture permeation for the sealant to cure in the hose and block flow. Blockage may take a few days or several weeks to form, depending upon the hose material, wall thickness, and the temperature and humidity conditions. To prevent premature cure, all seals and packing should be impermeable to moisture, like those made from Teflon and polypropylene. Hose runs should be kept to reasonable lengths to reduce pressure drops. A hose with an inside diameter of 3/4 of an inch is recommended. Smaller hose diameters will work, but they significantly reduce the volume of material available for sealing. This in turn can drastically slow the sealant installation. Daily cleanup or a flushing of the Teflon line system is not required. A small plug of sealant may form in the nozzle tip overnight, but this can be removed in the morning and the pump restarted. Wrapping the nozzle tip with aluminum foil or plastic will reduce the quantity of cured sealant in the nozzle. When the equipment and hoses are not used on a regular basis, they should be cleaned by flushing the entire system with a solvent, such as mineral spirits. All solvent residues must be flushed from the hose before sealant is installed in the joint. Keep your foot pace even for the best possible installation. Walking too quickly or suddenly slowing your pace may affect the amount and consistency of sealant placed in the joint. It may take some initial practice, but you'll eventually learn how fast to walk to achieve a consistent depth of sealant and to leave the proper recess. Providing that the sealant is properly installed, leaving the required recessed level, the roadway can be opened almost immediately to traffic. The sealant's curing process will be complete in 7 to 21 days, depending on the weather. After the sealant is cured, you may want to spot check to visually and numerically test the sealant's adhesive and cohesive characteristics. Cut the silicone sealant perpendicular to the joint and along the joint walls for about 2 inches. On this cut tab, mark 2 lines approximately 1 inch apart. Then pull the tab upward at 90 degrees from the pavement. At 450% elongation or 5.5 inches, there should still be no cohesive or adhesive failures. In addition, the cross-section of this tab should also be examined for a thickness of the final bead, shape factor, and width to depth ratio. If desired, this sample can then be completely removed, its location documented, and be kept as a permanent record of quality control. The test can be run as many times as needed and can be used to compare all sealants and job quality. On all of the test sites, as well as any small areas that may need repair, the repairs are quick and simple. Just cut the defect or test patch out so that the clean silicone remains. Then place new silicone in the void left. To simplify this repair step, Dow Corning 890 SL silicone joint sealant is supplied in convenient tubes. The new silicone material will adhere to the clean existing silicone, and within a few weeks, you won't be able to distinguish it from the rest of the joint. The bond will be just as strong as the original. The information presented here covers many of the typical situations encountered during sealant installation. For situations not covered by this training, please contact a Dow Corning representative.